All right, Advent of Code day 12. Another grid. Fencing. Okay. Um, sure. So we've got the grid. Um, ah, someday I'm gonna remember that. Chords by value. It's not even useful. It's probably not even useful. Yeah, it's not even useful. Yeah. Sure. Mm. Which is redundant for most. A lot of sections. Okay. Are here. 12 by 18. Um, so 18. That's what I thought. Um, that is just the number of orthogonal neighbors. Yeah, okay, okay. Mm-hmm. Yeah. Yeah. Of course. Um, mhm. 12 and 15. That's not right. What did I do wrong? Oh, right. Because this needs to be counted 12. Okay. So oh, yes. Actually, I can just do that. Then, yeah, yeah. Of course. Do that, and then this parameter should be correct. Um, I'm probably spelling that wrong. But 1930, that's good. Yeah, that was slow. That was um okay. Um that is an interesting twist. Great. So everything else here is the same. Um that's gonna be interesting. What I can do So you know what? Then I do compression. Because the way I've done this. Yeah. Yeah. Which is going to be the same as that. Um, I just do that, right? And then well, would help if I did that. Oh, close. Off by one. Why am I off by one? Outside. Actually, I'm not even sure this fully works. I'm going to be slow today. I already know I'm slow today. So I guess what I could do instead is actually just do this. Or no, dxdy. Yeah. Um, yes. Yes. Um, that actually gives me the perimeter too, but then we do. Oh, and that's why this doesn't even work. I only went single place. I needed to keep going, but I'm not convinced that even works. Yeah, that was silly. Right. But then, hmm and I could do turns, and I probably should, but whatever. Um, hmm yeah. Um, is that correct? That is correct. Okay. That's a janky little formula. Oh, and you're wrong. Of course. Yeah, R is good. V. I mean, all of these should be good. F is 10, 12, 14, 20. Yeah, those are all exactly right. So what if I go back to this, even though I don't think it's right? So I've got that more readily available. We don't do that. So these are wrong. This will be, yeah, you are completely miscounting. That's what I thought. And you're miscounting on, yeah, where's V? On a section like this. Yeah, yeah, that's what I thought. That's what I thought. Um, just out of curiosity, what number would this give? IU. Even though it's wrong, yeah, it's too low. Yuck. Okay. That's got the twos, which are bad. This is better. No, because you're bad. Um, you give me the right answer here. Hmm. 80? Yes, I agree. Or 36, yeah. Two 36, yep. So I agree on every example, right? You're not going to submit because it's the same number. What am I missing? And what am I doing wrong? Regardless of how long it is. I don't even know how to begin to debug this. I really don't. Oh, yeah, I mean, that finished a long time ago. Unless I can do this and just have stupid amount of data. But I really should do. Gonna be intractable. No, because you're wrong. Oh, okay. Um, area 2. Yeah, anything with area 2, area 1, these are trivially correct. Those are trivially correct. Anything with 3. Yeah, so what I should do actually. Okay, they're already in order. I don't need to sort that. Okay, I just have less to debug. Okay, so for this S, how many sides? Use A42. Let's count from here. 1, 2, 3, 4, 5, 6, 7. That's why it's counted, because I got 41. The number of sides must be even. So it's going to be 42. Um, just double check this. Oh, oh, oh. This is wrong. This is wrong. Okay. Um, yeah, that's just wrong. That's wrong. Um, I already know is correct for that. 1206. This should not break it. It should still be 1206, but now I comment this out. There we go. Yeah. Okay. Okay. Well, at least I finished. Whew. There is definitely a better way to count the number of sides. And whew, I was slow. I was actually legitimately contemplating uh not posting this when I was done. But I'm done, which is great. So let's walk through this. Um, this is really kind of a combination of two problems. One is just finding the area of sections, which is a standard flood fill algorithm. What's interesting is the perimeter here. So let's walk through how I did that. I got my grid. I've got my fill section. This is the standard bog simple flood fill of just taking a chord and flooding to all the neighbors to get the section. So I wanted to get these sections first. The size of this section is, of course, the area. The perimeter is a little more complicated. And let's see if I even remember what this was. So I was, uh, yeah, for every cell in a section. Let's take a simpler section. Let's go to an example. Um, so taking this right here. If we look for all the R's, we've got this nice block here. So every cell here is going to have some neighbors that are outside of the section, outside of this area. Now, the perimeter is then going to be comprised of a boundary here between the cells in the area and the cells directly outside. This is at least how I was conceiving it. So for this R block here, we've got one side over here with this V, one side here with that V, one side here with this C. And so as I was solving, my first thought was, okay, let's just count the number of neighbor cells to the area, which is almost correct. But the problem is we need to count some cells, like this one, twice. And in some other inputs, maybe even 3 times or 4 times, because this is actually the neighbor of this R and this R. So really, we don't just care that this is the neighbor cell, we care that this is the neighbor cell from a given direction. And so I was, when scoring a section, actually keeping track um, of which direction it came from in counting every single time I got to a cell, got to a neighbor that was not in the area. Originally, I think I was going to be doing a set here, and I actually got to that in part 2 to keep track of that direction, but it turns out to be easier just to add one to a counter here, and then we've got our perimeter size. So that's all well and good. Took me longer to do that than I would like, but got that answer, and that's all well and good. Then part 2, just counting the number of sides, adds an extra wrinkle here. Because now, as we can actually keep up on this example here, we can use the same logic to get to all the perimeter cells, but then we've got to just count kind of the neighbors, and that got really hairy for me. But what I ended up landing on here was then, like I was saying before, keeping track of the direction we got to this neighbor. So I actually am scoring the section and counting the number of sides in 2 steps. I'm actually still doing the same perimeter thing. And this time here, I am keeping track of which cell in the perimeter it is, but also which directions I got to that perimeter from. So this C, I know I got to it coming from the right and coming down. Then in the second pass here, we take a pass over all these perimeter cells and essentially mark off all the adjacent cells that were reached from the same direction. So, for example, this C here, coming down from this R, I can also mark off this C, because both of them I came down. Whereas this here, this is adjacent, but it's not part of the perimeter, and this is actually part of the area. So doing that at a high level conceptually works just fine, but there are some extra wrinkles to keep track of. Now, some of these examples will deal with it. Where is the nice example? This one here. It's not actually a great example. In my actual input here, somewhere we're going to find a place where the area kind of loops back on itself. And it may not be one of these S's, it's probably one of the other areas. Maybe a Y. That's almost interesting, but that's not what I'm looking for. This is close enough. This isn't exactly the situation I was thinking of, but it's close enough. So if we imagine this G was over here, we can even just copy this. That is, turn off word wrap and then we can copy it. Construct a little example here. Except this doesn't have selection. We'll have to just bear with a slightly janky example here. So these G's, I've cut off the top and bottom, but what I want to point out is that when I'm coming along this section here, this here, I know that as I'm walking along, these cells are all part of the perimeter. This is also part of the perimeter, but I came to it from below. I came up. This cell, I came from the top again, coming back down. So here, if I am not careful as I'm walking along the perimeter, I'm going to accidentally mark off this cell and this cell coming down as I'm trying to take care of this edge here. And that is what I was doing initially. If we go back to the solution where I did not have this check, I was just walking along. I knew the direction I wanted to walk on the edge, and I was just marking off everything so long as it was part of the perimeter. I said, oh, hey, I'm just going to keep marking off from that direction. It's all good. It's part of this side. And I kind of jumped this gap here because this gap, it's a gap in the side. It is part of the perimeter just because of this G down here. So what I needed to do, and what this very important if check is doing, is just making sure whenever I get to a cell in the perimeter, it's actually part of the same side. Because if I keep marking off, I'm going to ruin my side counts. So yeah, once I had that, then this somewhat mess of a loop finally was giving me the correct side count, and I was able to get the right answer. I am sure there are more elegant solutions to this, and I am sure the Reddit solution maker thread is going to be full of much, much cleaner and shorter solutions than this. So really, I do not recommend following this solution path. I am going to be cleaning this up and refactoring this to death, but yeah, this is what I came up with. Definitely wish I would have come up with this faster, but I'm just glad I got it done. It could have been worse. So yeah, for a moment, I really thought I wasn't going to be uploading the solution. It looked like I was in for a long, embarrassing, grueling grind, but at least I'm done. So yeah, I'll be back tomorrow.